So in this video we're going to talk about matrix multiplication by scalars. So if we have a scalar c, so a scalar is just a real number. What we're saying when we say let c be a scalar, we're just saying let c be any real number you want and let a be any matrix that you want. Then if you multiply c times a, in other words if you do c times a, all you do is multiply c by all of the elements of a. You scale them by the scale factor c. So here I have a matrix A and I have a scalar c, and it says find CA. So CA would be 5 times A, which would just be 5 times the matrix 1, -2, 4, 7, -3, 0. And all we do is multiply 5 times each of the elements of the matrix. So we really get 5 times 1, 5 times -2, 5 times 4, 5 times 7, 5 times -3, and 5 times the 0. And this is going to give us the matrix 5 times 1 is 5, 5 times 7 is 35, 5 times -2 is -10, 5 times 4 is a 20, 5 times -3 is -15, and 5 times 0 is 0. We could also go backwards with this. So let's say I started with a matrix that had even numbers in it. Let's say I had 2, 4, 6, 8, 10, and 12. If we recognize that every element in the matrix has a common factor, in other words, this first element is 2 times 1, 4 is 2 times 2, 6 is 2 times 3, 8 is 2 times 4, 10 is 2 times 5, and 12 is 2 times 6. That common factor then that shows up, the 2, the common factor could then be factored out using the definition of scalar multiplication. So we could get 2 times to be 1, 2, 3, 4, 5, 6. So sometimes it might be convenient when you're working with matrices to work backwards. The nice thing about scalar multiplication is it gives us a way to define subtraction in terms of matrix addition. So just like with real number subtraction, if we have 7 minus 2, we know that we can rewrite that as 7 plus -1 times 2, or just 7 plus the opposite of 2. Same principle holds when you're working with matrices. So if I want to do A minus B, I have 1, 7, -2, -3, 4, 0, minus the matrix 3, -6, 12, 21, -9, and 0. We could actually just rewrite that subtraction in terms of an addition, which is nice because that really identifies that you only need to formally define addition. You don't need to formally define matrix subtraction. So we could rewrite this as plus the scalar -1 times the matrix 3, -6, 12, 21, -9, 0. And then we could use scalar multiplication and distribute the scalar into each of the elements of that matrix. 1, -2, 4, 7, -3, 0, plus we'd get the opposite of 3, the opposite of -6, the opposite of 12, the opposite of 21, the opposite of -9, and the opposite of 0. And now we have an addition, which means that we add corresponding elements. So 1 plus -3 is -2, -2 plus 6 is 4, 4 plus -12 is -8, 7 plus -21 is -14, -3 plus 9 is 6, and 0 plus 0 is 0. So we can define matrix subtraction using scalar products of matrices.